Welcome back. This is the fourth video in the series, Getting to Know Cimatron NC. Today I'll be discussing remachine cleanup, rest mill, and pencil mill. Let's get started where I left off on the mold cavity. The smallest cutter used was a 1/4 inch diameter ball mill. I'll take a moment to review the curvature map. It immediately reminds me that the smallest radius on the part is 93 thousandths. And there are a few sharp edges to consider. In my cutter table, I've loaded 3 different 1/8 inch ball mills to remachine this job. Remachine and rest mill procedures support the use of ball end or bull-nosed end mills. Each perform machining in areas with corners too small for the previous cutter to finish. From the left, I'll select New Procedure to create a remachine cleanup. You'll notice Cimatron already has the geometry selected. As new procedures are created, they inherit the information from the last edited procedure. In this case, that was the Finish Mill procedure. From the Motion Parameters tab, I'll uncheck Multi-Cutters and choose the shortest 1/8 inch ball mill from the cutter table. I'll recheck the Multi-Cutters box and select 2 longer tools for the procedure. I'll jump back up to Tool Trajectory. Here you'll notice the Re-Rough option is checked. This will allow the system to check the remachine areas for excessive material. If found, the procedure will re-rough as required to minimize the stock. It's completed as a Z-layers rough spiral operation. This will greatly reduce the possibility of tool breakage due to excessive material. I'll set the re-rough to machine within 4 thousandths and adjust the parameters. This procedure will be used for roughing only. The machine regions are set to none. The procedure is contained by a boundary created using the previous tool, in this case a 1/4 inch ball mill. Save and calculate. Next, I'll create a new cleanup procedure with the machining region set to split horizontal and vertical. This simply separates the vertical areas from the horizontal areas. Other options in the cleanup operation include strategies like all along, horizontal only, vertical only, and none, which we just used. The remachine procedure also has fine surface options for user control point distribution. Save and calculate. Now I'll split the 2 procedures to highlight the cutter change. The shortest cutter machined the upper area of the detail, and then the system loaded the longer cutters to complete the process. Notice the vertical corners are machined using the Z-layer strategy, and the horizontal is a collapsing pocket. The second procedure I plan to discuss today is rest mill. It's contained similar to the cleanup, but the strategy is slightly different. It uses the same strategy available in Finish Mill by Limit Angle. This helps eliminate the blend issues caused between different machining patterns. I'll create a rest mill and calculate it with the settings the procedure inherited from the previous procedures. You'll notice the horizontal areas are done with a parallel motion, same as the original finish mill by limit angle. The final topic of the video is pencil mill. This process machines internal corners. The tool motions result in a final pass of the cutter, pushing into the corner, touching both the neighboring walls and floors. This is used to smooth out radii that are very close to the nominal size of a cutter. For this procedure, I'll be using a 3/16 ball mill. It has options for multiple passes, as incremental Z or surface offset. Both simply copy and offset the final pass. I'll accept the inherited and default settings, save and calculate. Navigate shows the cutter in the corner making a pass along the radius to smooth it out. This brings the video to an end. Please stay tuned for the next video, auto tilt, convert to 5-axis, and guided cleanup.